Okay, so we're going to talk about cloud native today. So briefly, I'm David. As Paul has said, I'm a software consultant. I organize quite a lot of user groups, which is actually why I'm not an organizer this year. I have quite a lot on my plate, as you can see by the list of user groups there. So big props to all the team. Thank you for organizing this for a second year. Everything looks amazing. And I'm also a developer. I'm giving a kind of DevOpsy talk. I'm a developer that believes if I write code, I should know how to ship it. And that's what we're going to kind of touch on today with the whole cloud native aspect. So I don't write PHP anymore, sorry. I just put it up there because I didn't want to come to a PHP conference and say I don't write PHP, but you know, I've done it now. I love Elixir, you should check it out. And if you want to learn more about that later, just come and speak to me. So let's kind of discuss what is cloud native, right? It's pronounced cloud native. I just put that up there for a wee giggle. And I'm the cloud nativist. Come on, wake up. And what does it mean? Yeah, there's no formal definition, so let's break it down. What does cloud mean? Less transparent. Gloom. Yep, definitely the cloud I know. So I'm really sorry. I don't know if you can see the slides against the white background, but those lines do not add up, and it really pained me. I couldn't get them to add up, but well, sorry. So we're going to start with the formal definition from the Cloud Native Foundation. The Cloud Native Foundation is a subsidiary of the Linux Foundation, and they're the people that are promoting this whole cloud native thing. So they're the ones that have the formal definition. And let's take a look at what that means. So we're going to start by talking about what it means to be containerized. So we want to take our applications, we want to containerize them. I'm going to assume everyone here is using Docker, right? Anyone still on Vagrant? You're dead to me. Let's adopt containers, right? It's going to make your life a lot better. So why do we want containers, right? Reproducibility. We want this parity between our development environment, our production environment, and any other environment that we're going to potentially have, right? I do not want to hear this one more fucking time, okay? I don't care if it works in your machine. If it doesn't work in prod, it doesn't work. End of. Resource isolation, right? The big, massive thing we get from containers is the fact that, right, we are separated from the kernel. We have no interference from other processes. Nothing else is going to mess with our stuff. So jails, that's the whole point, right? You do not want more than 1 minion in the same jail cell because bad things are going to happen. Containers are going to give us the flexibility, the security, which is a kind of side aspect of the whole jails. But just we know that from a resource level, we have this container, we can allocate it, 32 megs of RAM. If it's PHP, you probably want 4 gig. And just keep it running, okay? That's the last PHP joke I'm going to make, I swear. Transparency is one of the other tenets of the Cloud Native Manifesto. I don't know what they mean by that. No idea. I think that what they're trying to get at is by doing the containerization thing is that we have the Docker file. We're removing the magic from the operational side of our application, right? So you write your app, you have a Docker file, it tells it how to run. We know where each of the stages lie. I think that's what they're getting at with transparency. If I'm wrong, I'm wrong. But you should all just adopt Docker now. And that's the last time I'm going to say Docker until the last slide, hopefully. Dynamically orchestrated. So when we're doing cloud native applications, right, you're probably not having infrastructure in the sense that we have the whole pets idea, right? We're moving on to the cattle, we're doing all this provisioning, we're doing all this fancy thing. So we have to get really good at Tetris in order to do this. You want to be able to make sure that you've got, if you have 3 servers, that your containers are dynamically orchestrated in a way that it makes sense from a RAM and a CPU kind of point of view. And there are many ways to do that. We'll touch on a few of them later on. And microservices is the last tenet of the Cloud Native Manifesto. So, you know, you have to be able to write small services that fulfill a duty, and you have to be able to replace them whenever they don't fulfill the duty anymore. And, you know, that says itself, right? So why have 1 broken service when you can have 100 of them? Oh no, why does that not work? So you're all sold on cloud native, right? That's why we're here. So how do we become the cloud nativists, right? So we're going to look at some of the CNCF projects. The ones in orange are the ones we're going to look at today. And these are the tools that when you go back into the office on Monday, that you want to start bringing into your ecosystem or your infrastructure. So Kubernetes, anyone using Kubernetes? Awesome, that's really cool. Anyone using Docker Swarm? I'll help you migrate later, give me a shout. we're not going to talk about Kubernetes today. There is a really awesome talk on this afternoon, so come and see that. Kubernetes is an amazing tool. I'm not going to do it justice in the time that I have here, because I have a lot to talk about. So just make sure you see the talk at 3:30. Fluentd. So if you're going to do cloud native, you have to have centralized login, right? I do not want to see people SSHing onto their servers and tailing a log file. This is not how we do it in 2017. We have tools to help us with this. I heard a laugh. Someone's actually doing that right now, probably, right? You got downtime and you're SSHing. So Fluentd is written in C and Ruby. Please don't judge it based on the Ruby part. And it can handle 13,000 requests or events per second, right? I'm going to assume not many of you are dealing with that kind of scale, so Fluentd is going to be an excellent addition to your infrastructure. It's going to allow you to take all of your event streams, all your logs, and put them into a centralized location. And then there's loads of plugins, which we'll discuss in a second, that are going to allow you to take those logs and put them into Elasticsearch or wherever you need. And the memory footprint is really small, so Fluentd is a no-brainer, right? Let's get the logs off the infrastructure and let's get them into a centralized location. But if the Ruby bit annoys you, you can use Fluentd. It's a much smaller memory footprint. I couldn't find metrics on how many events are processed per second, so we're just going to say it's more than 13,000. And the memory footprint is under a meg, right? So if you are worried about performance or you're in that edge of the scale where 13,000 events per second just isn't cutting it, then Fluentd is probably your other option. Plugins-wise, can hook into all of the things that you have in your infrastructure. So if you want to get metrics or logging from your databases, from your Elasticsearch, from your Kubernetes cluster, or even from Docker logs themselves, Fluentd works seamlessly. You don't really need to do any configuration. So again, you can just run a container. You don't even need to run it on the host itself, and it's going to integrate with all of these services for you and centralize those logs. Configuring it for Docker just requires changing your Docker daemon configuration. So it's like literally 3 or 4 lines of JSON just to hook that up. If you're running in Kubernetes already and you're fortunate, then you can just run it as a daemon set. You'll find out what that is at 3:30, but you can run this and it'll just monitor all of your Kubernetes cluster for you. Again, very little effort, loads of benefits from nothing. Monitoring, the one thing that people always seem to get wrong is understanding what their application needs to run from a resource point of view and when things are going wrong. And for that, we have a time series database called Prometheus, which is another cloud native project that's written in Go, so obviously we love it. And it gives you dashboards for free as well, so you can actually just use Prometheus without Grafana, but I'm going to assume that a lot of people are probably using Grafana as it is, and it integrates natively. You don't even need to configure it. It's just going to pick that up and start providing you dashboards. So you can just configure. You can just tell Grafana that you have Prometheus available within your infrastructure, and it's going to find those logs and scrape that for you. Again, integrates with everything, like all of these software. I think the fact that you don't really need to write much configuration to get all this kind of value is amazing. Prometheus has exporters for everything in your stack, so Elasticsearch to MongoDB to Rabbit, Kafka, etc. But it also does scraping. And this is where the magic happens. You get this for free with Kubernetes as well, right? It's going to integrate with Kubernetes. It's going to understand the deployments and services that you have, and it's going to fetch those metrics for you. It just goes to /metrics. And all you need to do on that endpoint from your application is write a very simple text output where you have the metric, and then you can apply labels within the brackets. That's it. Right? The easiest code you're ever going to write. It's going to take you 10 minutes, and you're going to start to understand how your application runs within your ecosystem. If you really want, you can do this manual instrumentation yourself. You can expose metrics by the PHP library. So you just have to say, oh, I want a counter. This is the number of 500s, the number of 400s. Every time you get that, you can increment the counter, and those are available to you in Grafana or the dashboard as well. So again, very little effort, lots and lots of value. I'm going to assume that no one here is doing distributed tracing in their application. If you are, hands up. Awesome, one person. Tracing is it's an interesting concept. If you're writing in PHP and you're not doing microservices, there's probably no value. If you're looking to migrate your application to cloud native, if you're looking to adopt microservices, then you have to understand that a request comes in to your application, potentially speaks to dozens and dozens of services, and you have to understand where it goes, when it goes, how long it takes, all of these different metrics. You have to understand where the bottlenecks become in your application. You cannot do microservices without understanding this flow. Well, you can. You're just going to have a really bad time, and you're going to be working on a Saturday afternoon in a conference with your laptop out. So you don't want to do And OpenTracing is mostly a spec. There are some implementations of it, but it's primarily just a specification for people that want to understand distributed tracing. We have libraries for PHP, which is great, so no excuses for getting this into your application early. Even if you do have a monolith, you can start bringing this in now, and as you expand your services out, you can just carry on that kind of principle of applying the traces. So the value comes when you have more than one service, of course, right? So understanding, okay, I come into my API gateway, I have a user service, I have an email service, I have all of these different things, and where the requests go. One of the things you do have to do is start to generate request IDs. So you can put that in your API gateway, and then you just pass that around the service calls as you go. Oh, I've lost my screen. There we go. So those are the main things that we want to kind of touch on. We're now going to look at how we take our monolithic application and how we start to adopt these in our applications as well. So from the monolith, which I'm going to assume most people are working on at the moment, and how we start to break these down and how we start to adopt microservices. So you cannot, and I will not, in fact, you know what, I'll say it twice. You cannot adopt microservices without automation. If you're not doing continuous integration, you're going to have a very bad time, right? We need to be making sure that our deployments are safe. We have to do them often. We have to do them frequently. We have to make sure that we are comfortable with the process of deploying. And you're going to want automated tests. As your services grow, they become easier to test, right? You have no excuses not for integrating those tests very early. And you want to make sure that your deployment process is repeatable. Once you have this automation, you're on a very good roadmap. But you have to do this first. This is not something you can make up later, right? You do not have 1,000 services or even 20 services and not have this as part of your infrastructure. And it's just going to give you confidence, right? As your services grow, as you move from 1 to 3 to 6 to 20 to 100, you need to have the confidence that when you make changes to your code, that you have a safe and secure deployment pipeline. We also have to make sure our applications are 12-factor. Right? I'm going to assume most people have heard of this before, but we need to make sure that we have most of the tenants of the 12-factor manifesto as part of our development infrastructure. So version control. I'm not going to ask you to show your hands if you're not using it, but I know who you are. You have to have explicit dependencies. As PHP developers, you have that already, right? We have Composer. We're very fortunate to have such a powerful dependency management tool there. We have to make sure that we can configure our application at runtime. All right? If you have a prod.yaml, a staging.yaml, and it has all your secrets and all of your endpoints for your database, right? That's not good. That's a good start, but it's not good, right? We want to be able to pass in environment variables. We want to be able to configure our application. The reason we want this is we want to be able to stick our application in a container and deploy it anywhere. If you're building an image to deploy to staging and then building another image to deploy to prod, you're not going to have that parity that you want, right? The parity that's going to give you the, I know this application is going to work. So runtime configuration is very important. And that leads on to the build, release, and run, right? Make sure those are separate stages of your build pipeline, not one. You want to be able to build the image, and you want to be able to release it anywhere. And disposability, it's just, we want to make sure that our application is stateless as much as possible, right? It's obviously very hard. We have sessions, we work in the web, but removing as much state as possible from our applications is going to allow us to have this ability to deploy to any environment we need, at least push the state as far out to the boundaries as possible. And this makes us scale, right? One of the biggest challenges I had as a PHP developer was making sure my application could scale. I worked on a news website, and we'd go from 10 requests an hour to 50,000 requests an hour. It's hard to predict the scale. So making sure your application follows the tenets of the 12-factor manifesto is going to allow you to scale much more rapidly. Docker, hey! Hopefully you're all using Docker, right? We use Docker because it's cool. It gives us the Docker file, so we have this nice way of saying this is how I want my application to run. As developers, that is something that's obviously new to us over the last few years, but being able to say, this is my code, I know how to run it better than the ops guy, or work with the ops guy because it's DevOps now, but you want to be able to just have that power over, I know how my application works. So it's going to give us the parity that we need as well, right? It's so important that when you deploy to production that you know it works the same as it does in dev and staging, right? Again, falls back to the, it works in my machine, right? If it doesn't work, it doesn't work. So just start adopting Docker now. Stop using Vagrant. And logging, right? I've already spoken about SSH and into production servers. It is just a terrible habit. Obviously, you know what? Bad things happen. If you have to SSH into prod, fine. But just start looking, how can I get my logs off the machine? If you're running in containers, then you want to be logging to standard out, and you want to be collecting those through Fluentd, or maybe you're using Logstash or an ELK setup. But just make sure you're taking those logs from the container and you're putting somewhere that you can query. You also want to be able to do cross-sections. So once you start logging or centralizing all your logins, especially from a microservice point of view, when you can understand what happened in one service and at the same time something happened in another service, you can start to overlay those and say, oh, right, this failed because this service over here failed. I know why that failed, so I can fix that, and then this service won't break anymore. So very important that you just centralize this and you're able to understand your application a whole lot more. And if you're not doing exception tracking, you should certainly start looking into that now. There's a great application called Sentry. It's open source. You can run it on your own infrastructure. They also offer a paid version. Just understand that when exceptions happen in your app, you need to know about them before your users do, right? It's very important. And this just gives us a great understanding of how our application works. And that's very important, especially when you have 1,000 of them. But now we have a centralized logging. We need to know when something's going wrong or when we need to be able to scale. So, if you've got 1,000 services on a 10-node cluster, then, okay, when do I need to move to 11 nodes? When do I need to move to 12 nodes? When do I need to schedule more services? When do I need to deploy this individual service rather than this other service, right? You're not going to be in a position where you just say, I'm going to run every service once and things are going to work. Sadly, it's not that easy. So we have to be able to monitor our applications. We have to understand when the resources change. So just understanding your limits, being able to scale, particularly on a service level, is really, really important. Prometheus is one of the best tools out there you've got in the cloud-native landscape. Again, the integration is super simple. There are absolutely no excuses. If you're using New Relic or Datadog, awesome. Keep using those. Just make sure you understand. This is a personal slide. I did have some very eager scaling rules at one point in my application, to the point where I overloaded my database by having far too many web applications. So, be careful. Don't scale too quickly that you're actually DDoSing yourself. It happens. And that's a story I'll tell you in a pub later anyway. So, but I think monitoring gives us psychic abilities. Just being able to predict, when the latency of my application goes above a certain threshold, when I'm unhappy with the response times, yes, I can scale this service, I can scale that service, I can scale everything across the stack, and I can get a lot more bang for my buck. So psychic abilities are awesome. No one's ever going to turn that down. And microservices themselves, right? So we have the automation, we've got our centralized logging, we have our monitoring. We're now in a position where we can safely deploy more than one service, potentially hundreds of services, and know that we have the confidence to do it. And that's one of the main tenets that we need. So, why are microservices cool? How many people have tried to justify refactoring to their Scrum Master? Who actually got the time to do the refactoring? You liar. It's quite hard. We can call it technical debt, and we can maybe get a bit more bang for a buck when we speak to our project managers. But realistically, when you say, I want to make my code better, and I'm not actually offering our users any more value, it ain't going to happen, right? So the really cool thing with microservices is, right, you don't need to refactor, you can replace it. If your service is small enough that you can rewrite it in a couple of days or a week, just do it, right? You don't even ask for permission. Just apologize there. But when your services are small, testing becomes a lot easier as well, right? If you've got a small microservice that does authentication within your application, being able to test that becomes really trivial. I know, TDD is hard, right? People come up here and say, oh, you should do all this testing and you get all this value, but it's very difficult to adopt. So when you adopt microservices and you look at your testing for a single service and you're like, oh, it's like 20 lines of code. Like, okay, I can do that. We're getting to a stage where it's a lot easier to do that. So continuous integration and deployment of a microservice also becomes really trivial because, if I deploy this service and something goes wrong, I'm probably only affecting that service. We're hoping that we don't have enough coupling across our entire stack that, if one service fails, oh shit, we've just taken down our entire application. Probably not microservices, right? You want to make sure that you can deploy fast and you can fix things fast as well. And onboarding, right? We are developers. We don't work like in an isolation. A lot of us pretend to. We work in dark cupboards with green text and a black background. But onboarding when you have new developers becomes really trivial as well. So, you hire someone and you say, hey, you work on this service. It's 100 lines of code. There's not a lot of cognitive overload there to understand that service, especially not for making changes. You hire a developer and you show them your application where you've got 10,000 files and 100,000 lines of code. Very overwhelming, very difficult to get people on board. Even the test coverage at that point is going to be very hard for people to really understand when they make changes that they have the confidence that they've not broken anything. So lots of cool things for adopting microservices. And it gives us agility from developers, but also business agility. So we are able to spike things a lot quicker. We can do a lot of proof of concepts. We can take management on a journey with us when we say, we're going to try this thing. It may not work, but it's only going to cost us a week. Cool, you can just do that anyway. So adopting microservices in cloud-native architectures, confidence, scalability, idempotent, which is just a fancy word for repeatability, mostly. Understanding our infrastructure, super mind-reading abilities, awesome, and agility. Anyone not sold yet? Job done, I can go home, right? Bonus stage, right? Once you have microservices, you're in a very cool situation because we have this new shiny concept of the service mesh. Who knows what a service mesh is? You just keep lying to me, man. We need to have a chat. Service meshes are awesome. We get so much value from service meshes. We can do load balancing across our services for free. Our application we can configure once, and we can have load balancing that happens in the infrastructure layer rather than the application, right? You want to move away from saying my services live here. We want the infrastructure just to say, well, you want your application to say, I want to speak to my user service, and that just knows where to go and get it, right? And service meshes are going to help you do that. Canary deployments. Once you have microservices, if you're releasing something you're maybe not sure about, or you just need to be able to deploy it to like 25%, 50%, 75% of your infrastructure, then canary deployments are the way to go. Because you've got your centralized logging and your monitoring, when you do the canary deploy, you can see, okay, things aren't breaking. We can keep going with this, and that's awesome. When things do go wrong, you want to make sure they don't go wrong for long. So if you do a deployment across 25%, 50% of your infrastructure, you want the circuit breaker there to say, hey, this service isn't working anymore. Let's just cut it off. Kill the service, deploy something else on top of it. So the circuit breakers become really important, especially as your services grow. With the service mesh, we can also do timeouts and retries. I'm not sure how many of you have tried to implement exponential backoff in your PHP applications, but it can be very, very painful. And again, these are not things that from a software developer you want to be spending time on. So we can push that again to the operational layer. You shouldn't have to deal with it. And fault injection sounds really silly. Why would I want to make my application fail? Because you need to know how your application fails and make sure that you're comfortable with that as well. So using the service mesh, we can actually say 5% of my requests, I want them to fail. Why not, right? You want to make sure that you've got the logging, you want to understand how they fail, and you want them to fail well. That's the key thing here. And MTLS, we want to do mutual authentication between all of our services. I want to know when I speak to my user service that I'm speaking to my user service and that no one else has spun up a container on my public open function cloud or something and mining bitcoins when I try and speak to it, right? So just having that layer that says, yes, this is definitely what I want to speak to, it's confirmed on both sides is very important. And again, these are all things that as developers, you do not want to spend time on it, but you really, really want them. So how do we get load balancing? So all of these examples are based on Istio. It is a product that is built on the back of Envoy, which is a L7 proxy by the people at Lyft. And Istio is a collaboration between Microsoft, Red Hat, Google, some other companies. I can't remember them all exactly. But they took this proxy and they said, let's add some really cool stuff to it. So if I want to speak to a user service or I want to speak to another service in my application, I can just say, OK, when I request the source, which is a user service, and we can version the services, which is another really cool thing. So we can have version 1, 2, and 3 of this user service running across our cluster, and this will handle when my application should speak to it. I can say that the user service wants to speak to the email service, a specific version of it, and I can just tell it to do round robin. And it's just going to go away and speak to my Kubernetes cluster or my Docker Swarm cluster, and it's going to deliver that traffic for me. So from an application point of view, you don't have too many complicated configuration parameters to deal with. You just get this by providing a very simple YAML format and deploying it. If you have the canaries, again, we can say we want to route to version 2 and version 1. We want to monitor our logs and our metrics to make sure that nothing's going wrong. When we're happy with it, we finish that deployment. Very simple, couple of lines of YAML. Again, you're not doing anything, but you're getting a lot of value for what you do put into it. Circuit breakers, so we can just say, I want a simple circuit breaker, and I'm going to kill this service off after 100 requests. For no real rhyme or reason, after 100 requests, I'm just going to kill it, and I want to make sure my application handles that very well. Again, a couple of lines of YAML, and we get that for free. Timeouts and retries. Now, I spent a lot of time in my career making sure that when I go and speak to like a YouTube API or a Google API or anything else, that if something fails, I don't really want to deliver that response to my user. I want to be able to retry it. Then you have to get into the position where, okay, how many times do I retry within a small period of time, and do I add delays? And it's very complicated. It's not trivial. So again, if you stick Istio into your infrastructure, then you can just say, okay, if any request fails, I want to retry it again. There's going to be a timeout of 10 seconds, so I'm not going to wait too long to do it. And I want to try it 3 times before I actually deliver that failure to my user. Sounds fair enough to me. We can do that in 6 lines of YAML, and we deploy it. Immediately, our applications have the ability to retry any failed connection. Fault injection. Weird one, but we just, again, it comes down to when you have so many services, right? It's hard to predict failures, so you're as well causing them yourself. I mean, I don't know if any of you have read the Netflix stories, but Netflix have released a few products now where they take down entire machines within their AWS infrastructure. They've even written software that will take down an entire region of their infrastructure. Sounds scary to me. But when you're able to take that uncomfortable situation and say, well, it's not that bad. What happens if we do it? OK, things fail. And then you plan around that failure. Then you again have this confidence that, OK, things can go wrong, and that's OK. Like, who once woken up at 3 a.m. by PagerDuty? Definitely not me. So injecting these faults, just arbitrary number, right? I'm not going to tell you, oh, you have to do at least 10% and you have to inject all of these failures, but just have enough that you get uncomfortable and then plan around it, make sure that things are happy. So that, again, YAML, right? Everyone's doing YAML these days. So we can say we want to have a delay in some of our requests. We just want them to take a little bit longer. We want to see what happens when that happens. We also just want to kill a few requests. So we can just inject an arbitrary HTTP status, 400, 500, whatever. And then those requests are going to fail, and you plan around it. So Istio, hopefully I'm selling it well enough, right? But just by having this in your cluster, just by configuring this YAML, you don't need to do anything. And that's the beauty of it, right? You get all of this stuff. But you get the tracing. Right. So we talked about OpenTracing and hopefully saying, oh, this is amazing, right? We want to be able to follow a request all through our infrastructure through 100 different services. We want to know how long it took between each stage. We want to understand the latencies. Istio, if you use it as the proxy to your entire infrastructure, will monitor and log all of this to some sort of OpenTracing implementation for you. So you can just go to a dashboard and you can say, okay, it took 3 seconds to go here. Hopefully it didn't take 3 seconds, but maybe a few hundred milliseconds to go here and then here, and oh, I've obviously got some sort of latency issue here. So just being able to get that for free, I expect everyone to have Istio installed within the next hour, essentially. But beyond that, you get MTLS. So every time you run Istio, so let me clarify, right? You don't run one Istio in your environment. You would run Istio for every single service, right? So if you have a container that runs your application or your small service, next to it, I want to see an Istio. And I want all of your communication from that service to go through Istio. As you do that, you get the tracing, but you also get the MTLS. So it's saying, OK, so even if you're not doing TLS within your infrastructure, right, because that's a hard thing to do, you can have Istio do that all for you. So it's going to proxy all your requests. It's going to do the mutual authentication, and you know that everything's going to be secure. Again, you don't even need to configure it. It just works. So if you're using Kubernetes, you can adopt a sidecar pattern. Really easy to do. A couple of lines of YAML. You just say, run this container next to all of my other containers, and it goes away and does it. So you have tracing, logging, metrics. When am I cloud native? I think you can consider yourself cloud native. See, when you're staring down 100 broken services, and your answer to the question is, how do we fix this? Is, I'm going to fix it with another service. Probably when you can say that you're now cloud native. Thank you very much. If anyone has any questions, I'd be happy to take them now. You can clap, come on.
Give it 10 minutes early, so.
Oh, thanks, man. Cheers for telling everyone that.
There's plenty of time for questions.
Yeah, plenty of time for questions, please. There's a lot of content to consume here. I think really what I want to portray is just that, you know, it's not like a pipe dream. You can adopt microservices. There's only a few things that you need to get right up front, right? Automation and deployment and builds. You have to make sure you're monitoring things. And you have to have centralized logging. Once you have that, you can start rolling out as many services as you want. Hopefully, I've given you enough clue about the applications that you need in order to get to that point of view. And if you do have any questions, now is the great time to ask them. And if not, I will be hanging about all day. So, James.
Sweet. Wait for the microphone so that when the talks are recorded, when people are listening it back, they can hear the questions and the answers as well.
Hello. So I'm totally sold on this kind of thing for large apps, but my question is for small apps, is this a case of parameter optimization? And when you have a small app, at what point would you suggest adopting various parts of this?
Oh, we're starting easy then, okay. Yes, microservices is a great solution to complexity because we can push that as far into the service as we go and we minimize the complexity, of course. But for small applications, oh man, I wish I had a good answer for that. Judgment, I mean, everything we do comes down to our experience and our own judgment. I would say, you know, start with microservices because even if you've got a small application, just understanding the operational overhead of deploying, building, and managing services, even if it's only 2 services, right? And they both just do a couple of things. You're going to build the pipelines. You're going to understand how to do deployments, canaries, making sure you've got the MTLS and the tracing. Just having that early is never going to be a bad thing, right? So just go for it. There's never not a time to do it, hopefully, unless you're I don't know, writing some sort of tweet importer or something, and that's all it does, fine. Maybe it's a service on its own, but just do it. Understand it. Get it right. Amen. Run, Paul. Run.
Hi. Congratulations for the excellent talk. Running databases inside of containers. Many people don't advise it. What is your opinion?
Can you repeat that?
Running MySQL or Postgres databases inside of containers, many people don't advise it. So
people are wrong. So you're talking about running stateful applications in containers, right? Obviously, it's tricky. Yeah, of course. Docker provides volumes, so you can persist that state between container runs. It gets trickier as you try and maybe scale out those applications. I would just say adopt Kubernetes. Kubernetes is this really cool thing where if you say, I want to run MySQL in a container, I want 3 of them, you can assign like a persistent volume. And every time that container gets rescheduled, maybe to a different node, it will detach that volume and reattach it back to that node and then put it into the container. So running MySQL, any of these kind of stateful things inside containers is fine. Yes, there's concerns, people aren't happy with it. Just do it. I mean, again, get comfortable with uncomfortable, right? If it makes you feel uneasy, get better at it. I mean, it's a challenge, of course it is. Everything we do is a challenge.
we love challenges.
It's our job, right? We solve problems. So I would say definitely run MySQL, run Rabbit, Redis, all of these things in containers. If you're running Redis as a persistent store, you're in trouble anyway. So that's a different talk.
Thanks.
Hi, 2 things.
The liar.
Yes, absolutely. So first thing, I'd like to explain your point about the OpenTracing and Prometheus and such. For me, the important part of that, from real-world experience, is being able to trace the user delay from each of your microservices. So when you've got that situation of day 0, you've got no users. Day 1, you're suddenly creating a big national service. That's actually saved me in real life. We were able to see the delay at which service had caused the delay and instantly go and scale that out or fix that delay problem. So that's great. In terms of the question, so you talked about mutual TLS. I haven't used this service mesh that you're recommending, but you're saying it magically handles mutual TLS for you. But if your service is talking to it, what's authenticating your service talking to it if it's not running in the local context of your service? If you're running it as another container, then you're just connecting out to it in the network. So how could I not then do interception and play with DNS or play with however your service discovery fabric to that the proxies working? And the way I've got around that in the past with using other type of services is to run those locally within the context of the service, so in the container or in the VM.
Did you just answer your own question?
What?
No, right. Okay, so, I mean, a lot of the examples I've given just now are on Kubernetes, and I didn't go into Kubernetes in any detail whatsoever, right, because we do have a talk coming up on it. But so the way that the pod works is that everything does speak on a local network. So SDO runs, and it's available on 127.0.0.1, right? So you can trust that you're speaking to SDO right away. And then it's doing the TLS between all of the services, right? I mean, TLS is one of those things we all know we should have it even in our own infrastructure because, the NSA exists. But it's really hard to do it. Right? Generating certificates is tough, and then making sure that it's just too much work. Just running SDO as that kind of inside of your pod, letting all your traffic go through it. Just let it deal with it. I mean, fine, you might not have the confidence that no one else has ran something in your infrastructure, right? That's a different problem, but just having the TLS from service-to-service communication is very important.
And then using Vault to handle your certificate generation or something?
Have you ever managed a Vault cluster, man? Holy shit.
It beats like free IPA and dog food and
yeah, I mean, Vault is a great product. I just hate doing the operational bit around it, and then the whole unsealing thing. I try to automate everything, and automating that is obviously a challenge. In fact, even automating it defeats probably the point of using Vault in the first place. But that's a different story. No, Vault is awesome. Yeah.
But you know something's broken when they tell you don't automate this piece, and that's what they tell you with Vault, right? So that's
exactly,
that to me is a bad smell. But I haven't found a better solution.
Well, I'll tell you what, we'll grab a beer later and we can chat it out.
Thank you very much.
Cheers, man. Any more questions? Oh, one.
So I'm coming from a background where I am trying to migrate away from a big, scary 35-year-old monolith, and I'm trying to encourage management that this is what we should be doing. How on earth do you justify such a big leap and such a technical thing to somebody who's not technical?
Tell them it's agile. You make false promises, right? What you don't tell them is that the operational overhead of running microservices is difficult, and it's going to take any team in the world a long time to get the centralized log and the monitoring, all these tracing things in place, right? It's not going to happen overnight. But you have to start making those steps. But when you're trying to justify microservices, it comes down to, well, if my service has 100 lines of code and it's completely tested, you're going to have much more confidence in that than your 30% coverage in a larger application. It's going to allow you to move quicker. You can spike out services really quickly. You can test deployments. Like, there are so many benefits. And I joked about Agile, but it does give you a lot of agility in what you're doing. So I would just pitch it that way. I think we're done. So thank you very much. Hopefully you've all learned a little bit about cloud native. Hopefully you're all going to adopt microservices and you're going to do all these awesome things. There's a join down link there. Please give me some feedback. And thank you very much for your time. Cheers.